where it's talking about the required motor maintenance specified by manufacturer's manual. So your lubrication, one of the questions yesterday was one thing you got to take caution with, getting too much grease on. The bearing problems may cause expensive loading prior, excessive loading, poor lubrication, or installation of improper type of bearings. Okay, so we have to make sure we keep the bearings, the right size bearings, and keep them lubed. Motor temperature. The other is checking the temperature of the motor. Okay, you have your gun, and then just hit it. Hit something. Hit the motor and get the temperature of it. My computer is at 80 degrees. Okay, so it's always wise to check the temperature of the motor. Make sure the motor is not overheating, that the motor is running within its specific temperature range. Rotor and stator, make sure the gaps, make sure everything is even on your rotor and your stator. The gap is good, your bearings are good. The belt tension should be checked. You don't want a belt too tight, you don't want a belt too loose. So it has to have a certain tension in it. Motor mounts. Visually inspect the motor anchor bolts and concrete pad for signs of wear. You know, that motor turning on and off, on. Okay, it puts a torque on the base that's mounting it. So you need to check those anchors, make sure they're loose. Why? Because you don't want the motor sitting there wobbling. Okay, that causes problems. And in the motor controls, we want to make sure to keep the motor controls clean, test moving parts, and contact the regularly overload. Relay settings should be checked, also checked. So your settings, make sure the settings are set to the motor. So again, if it's 1.15 or greater, 125%, the 40 degree Celsius temperature rise, 125%, all of the motors is 115%. Okay, so always remember, check your overloads, make sure they're sized properly. Why? Because if these aren't sized properly, and then you can cause problems within the motor to fail. Okay, because the motor can be overheating, and this is not tripping out because it's set too high. This was an electronic one, and it has a little dial. You just turn the dial. And then we have the magnetic ones that I showed you at school, and again, those have to be sized according to the size of the motor. If they're too big and the motor starts to get hot, it doesn't trip out when it's supposed to. Why? Because your only protection for that wire, you know, when we set the breaker is not an overload protection. The breaker is a short circuit ground fault protection, because it's going to be set at 175, 250, or 300%, maybe even 800% if you got an instantaneous trip break of the motor rating. So, but our wire is only at 125%. So if our breaker is at 250, we're using a breaker and it's at 250. You know, we're exceeding twice the amount of what the wire can handle. Why? Well, that's where we rely on the overloads to protect the circuit. So we have to make sure that they're sized accordingly and that they are working accordingly. Transformers. Check transformer temperature, oil level, and gas pressure. Okay, for most parts of transformers, either dry type. If you're using a big transformer to feed a big thing, in this dry type, so we need to make sure that we check the oil levels. Okay, would be wise when you have your highest load of the day, check temperatures. Okay, make sure that if it has fins on it, that it's not exceeding a certain temperature, because the heat can cause your motor to fail, your transformer to fail also. So we need to check temperature. Need to check, make sure the oil's proper, at the level it needs to be. If you have a dry type transformer, maybe clean them out every once in a while. Make sure there's enough air circulating so the heat, you know, it's not too close to the wall where it's entrapping heat instead of releasing heat. We had one where somebody went and put it all the way up, got transformed, put the transformer all the way up against the wall. Well, where the fin came down, it hit the wall, and what was happening is the heat was hidden. Here's the fin is like this. Here's the wall. So the heat was coming and pushing the heat down. Well, where's the heat going? The heat is going back. It's pushing it down, and then it's sucking it right back up as the air, a little bit of the air that it was circulating. Transformers start to get hot. It was sized at about 90% of its limit, so that could have been some of the cause for the extra heat too. But the transformer went bad. So when we went back, we changed it. We moved the transformer forward. The transformer was only about 1.5 years old. So we moved the transformer forward and we increased the size on it to bring it back down around 70%. But make sure your transformer is not overloaded. Testing. There's 5 broad categories for testing in the electrical equipment. We have factory accepted testing, field proof testing, installation accepted testing, planned maintenance testing, and troubleshooting. Okay, for the factory accepted testing, okay, that's done at the factory. So the factory makes this, and then their engineers get there and they check it to make sure it's going to work according to specifications that it was designed for. Okay, or they can have an independent testing company. So say a company asked another company, can you make us this, and then they give them plans of what they need built. And then that company builds it. Well, and then they grab it to make sure it's going to work according to what they designed, and it was built according to the way they designed. Okay, field proof testing equipment is installed, but before it is energized. Okay, so field proof testing is when the equipment's built and they bring it in. Okay, when I worked at the meat processing plant, we bought a lot of new machines while I was there. The machines were all German. So we had a little hard time because when they sent all the literature to it, they sent us all the literature in German. But they had an engineer that put them together. So he went through everything and he taught us everything with a little bit of English that he did have. He taught us what to look for and everything else. And then we turned the machine on. Okay, and then we got the machine working. Okay, so that was good. When I was working at the university as a maintenance electrician, maintenance electrician, whatever you want to call me, because I did everything there. We also had, I worked when they put in MRI machines. I wiped out my wallet a couple times because I walked into the magnet room with my wallet in my pocket and I forgot to take my wallet out. So I walked with MRIs, CAT scans. I walked with the other different equipment for other different things. Okay, they buy these equipment. An engineer from the company comes in, or the seller comes in. They put it together and they do a test run, a dry run. What do you want? I call it a dry run because they're looking at all the components that it's going to work the way it's supposed to. Okay, so they go in there and then before they turn it on and work it, they check every component, make sure it's all tied in the way it's supposed to. They take ohm readings. I'm sitting there, I see them with a flute tester, and they're taking ohm readings, make sure that the ohm readings that they're getting is appropriate to whatever's it. No shorts, no faults, ground faults, or anything like that. Installation acceptance testing after new equipment energized. So now they get it installed. Now they did a test run. They checked everything. They feel everything is good. Now they turn it on. So installation acceptance is similar to a field proof testing, except these tests are done after the new equipment is energized. Data recorded at the initial stage is saved for future use. Initial test readings establish excellent baseline comparison data. So that installation, once it gets in, and then they work it to make sure it's going to work according. Before they sign off that, hey, you know what, we gave it to you in good working order. They sign it off. They give you a piece, your little work order. They said, boom, it's ready, it's working. Here. Okay? So if you have problems down the line, you can go back, okay, what you do wrong. Plant maintenance testing. Plant maintenance testing is set intervals over service life of the equipment. So some equipment you may have to do preventative maintenance every month, or every 3 months, or every 6 months, or every year, whatever it may be. So it's preventative maintenance. It's a schedule that's set up. There's a couple of that work in that, and you have that work in areas like I did that you have to preventive maintenance. Like when I was working in the hospital, we had to do a ground fault receptacles. We had to go around testing the receptacles every month, make sure they're all working. So I had a little GFI tripper thing that I would plug it in and set it. It had a dial. It was made by Hubble. Had a dial, and you turn the dial, and it would trip. And make sure it trips, because they're all hospital grade. It had to trip at 4 milliamps. So it had to dial. If it tripped up, If it tripped past 4 milliamps or it didn't trip, I have to change it out. The other thing I have to do is I have to go around doing spring tests. There's a special thing, you plug it in and you pull it and it has a spring on it, and you read the pressure before it releases, and these are all hospital grade receptacles. So they have to stay within a certain pressure so nothing unplugs by itself. Generator test in the hospital. You have to do generator test. I came in every month, turn on generator. So sometimes it was every 2 weeks. I think it was every 2 weeks. No, it was once a month. So I'd come in and do generator tests to make sure that they're going to work the way they're supposed to. Okay? Been a while now, so it's just okay. Those are preventative things. The engineer walked in, he checked the oil levels, he checked everything. My preventative maintenance is I'm not worrying about the generator. It's the transfer equipment. Make sure it's going to transfer when I need it. It's like how many of you test your GFIs? How do you know your GFI is going to work if you don't test it once a month? The way the manufacturer specifies is preventative maintenance. That's what we used to go around doing in the hospitals. Troubleshooting testing. Varies greatly depending on the type of equipment being serviced. There are several tests that are common to troubleshooting many different types of equipment. So again, you have a problem with equipment. What caused the problem? So you have to troubleshoot it to fix it, so you don't have this problem again. We used to have a problem with when I was working in the meat processing, that all of a sudden we have a whole pallet of bologna, ham, whatever it may be, because the cutter that's cutting the packages, because they were packaged in two. Okay, so we had a special cutter that cut it right in the center. Well, sometimes the cutter would, if they bumped it or whatever, it would throw it off, and all of a sudden it's not cutting straight down the middle, so it's cutting part of the package where the sealing was. So all of a sudden, instead of being cut even like say my hands, all of a sudden say one is like this, and this has got 4 fingers, this has got 3 fingers. Okay, it's because it went over to the side. So now it's like this. So now I got 5 fingers and 3 fingers. So, and then they would send the whole pallet back. Well, you can't have that. Why? Because you just spent, so many man hours cooking that ham, cooking that bologna, slicing the bologna, packaging the bologna, and then all of it gets sent back when it gets to the inspector. So there's a lot of the preventative maintenance to make sure that you have plant troubleshooting is getting it so it's where it's supposed to be. Working in the factory, it's hard because everything has to be to a certain thing, especially when you have to meet certain inspection protocols. And if it's not there, guess what? It gets sent back. Do it again. And guys in the office don't like that, because that's a thing on us, not the people working on the equipment. It's the people maintaining the equipment. Insulation. So it says some of the different troubleshooting testing. Insulation resistance testing, use a megameter or a megger, and it's a special thing. You put it on. You can do it on the motors, or sometimes it's a battery and it's got a battery. It's electronic. You hit the button and it sends a signal and it gives you a reading. The other is a crank one. I showed you all the videos in class when we were talking about tools. I showed you the things on in the last class. On they're going to be talking about ground testing. In electrician too, when we're talking about swimming pools, I showed you those 3 videos from Mike Holt when he's talking about swimming pools, and I think about 4 or 5 videos on swimming pools. That's why I didn't show him this time, because you already had seen him. And he's doing a ground test, and I showed you the ground test. And he's doing the equipotential testing. So he's going around testing everything. He's testing the ground rods. That's when he got the 5 ground rods, and he stuck them straight down, and then he tied in 120 volts to it to find out what the resistance was, so he can find out, because the cut says you got to have 25 ohms or less to ground. I'm getting ahead of myself here. But the insulation test, you can use insulation test is testing the motor. Make sure the insulation of the motor is good. Testing the transformer. Make sure the insulation on your transformers from the windings are good. Last thing you want is the windings, the insulation to go bad between your windings, and then your windings blow up. It says there are several types of insulation resistance tests, each designed to certain to detect certain characteristics of the conductor insulation. And then it has a high potential test on conductor insulation. The high potential test or high pot test determines the condition and reliability of the conductor insulation by applying a high AC voltage to the conductor for the short repetitive motion. So the high pot test is when they do. So like the one where I showed you where they're making the transformer, and they do a test, a lightning test, that the transformer can handle a lightning strike, because there's going to be spikes. So they're shooting 200,000 volts into a transformer to make sure it can handle it. Same thing you do on an insulation. Some of these older makers, they have a crank, and you crank it up and it sends out 1,000 volts on the line. So you have to be very careful. Why? Because you want to see how much of it escapes through the insulation. Protected device test. Protected device test on relays, circuit breakers, instrument transformers, and switchgear components. Okay, that's like your GFIs. When you walk over to the GFI and you hit the trip button, you're testing it. You know, we used to do the once a year for our big air breakers. We test them once a year, or sometimes we test it like in the hospital. We tested them every month. Okay, or every 3 months. So we'd come in and turn the generators on, put it in bypass, walk over to the big air breaker, hit the trip button, trip it out, then reset it. Okay, we were exercising the breakers. Okay, same thing with these. How many of you go exercise the breakers at your house? Okay, turn them on, turn them off. You don't have to do it, but you know, say that's something you should do at least once a year. Why? To exercise the breaker, make sure if it trips, that you can turn it back on again. So that's why we used to do the on the big air breakers, because you know we're talking about a 1600 amp, 1200 amp, 800 amp breaker that's controlling part of a building. So that breaker trips, you want to make sure that it resets again. If it doesn't do it, we took it out. We always had a spare. Put the spare in, then set that one out to get tested and remanufactured, re-certified, and whatever else they did. Transformers and switchgear components, making sure everything's bolted down. If we had a planned outage, okay, like we had some dry type transformers and we cleaned them up once a year. So we go in there, we turn power off on the high voltage side, because we controlled our own high voltage. So we go in there and go to the plant, turn off, switch off the switch gear, and then isolate the transformer. Go in there and discharge it with a piece of wire to ground. So we discharge the transformer, and then go in there and clean it. And then with a torque wrench, make sure everything is torqued properly. Every bolt, make sure the bolts were torqued properly. So we did this on transformers once a year, dry type transformers. Okay, switch gears, we turn them on and off. When we turn power off, we turn them on, turn them back on. After we got them, when we cleaned them, we turn power off, turn them back on. Grounding electrode resistance test verifies grounding integrity. So checking your grounding. Grounding test, so you can use a megger. You can use, they make it one like for ground rod. You can use your amp probe to find out, you know, what's your resistance to ground. You want to make sure that you have a good solid ground on things. So you have to make sure everything was in. Yeah, I told you where they had a problem. They got called into a chicken farm because the chickens weren't laying eggs. And so we went there and we started testing, and from the metal cage to the ground, we're getting like 3 or 4 volts. So where were the chickens laying eggs? They were getting shocked. You know, they're in the metal cage on the metal floor. So there was a difference of potential. Okay, we went to where the groundings were. The groundings were all rotted out on the steel, on the wrought iron, on the thing going up, because they grounded above ground instead of grounding them underground. So we went in there, we cleaned off all the grounding. In some areas they didn't have a ground. They just had a ground rod going to the metal. There was from the aluminum shed to the metal frame, they had a piece of wire to bond everything together. It was kind of, so we make sure we ran ground wires, we ran new ground wires, Some areas are using number 12, so we ran on number 6, and we grounded everything out, and sure enough, we were there. We got done with everything, we cleaned up everything, and we're doing some other things. All of a sudden, bloop, 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 you start seeing the legs dropping. Yeah, by the time we left there. Okay, thermal inspection test detects hot spots. So using the thermal reader, this test is used to detect hot spots in switchgear, motor control centers, and other parts of the electrical system. This is an effective way to determine bad splices. So sometimes when we have breakers tripping or anything, we have a special infrared camera. And if we had breakers tripping, I have to do this also part of my maintenance in the hospital that I have to do once a month is I get out this infrared camera and go to the panels, take the panel covers off, and take a scan of each panel. It's one of the jobs I hated. One of the things that I hated most was taking panel covers off because of this. So when I go on things, I hate taking panel covers off because I have to do it once a month. I had 8 floors with 6 to 8 panels on each floor that I had to take covers off. So I would pick 1 week, 2 weeks. 1 week I'd do 2 floors, another week I'd do another 2 floors, or whatever it was, because I had to do this every month. Okay, get my infrared camera, take a recording, get my recording. If I found any hot spots, I had to go back to the book and sit down and write it in the book. Same thing with the GFIs. Yeah, I'd go in there and I said, okay, fine. I tested these rooms, this room, this room, this room, and then I had to change them out on certain rooms. All that had to be logged. Why? Somebody from the hospital come down. They had to make sure that the preventative maintenance were being met. So going back, transformer. Okay, you get a panel. You know, you can use one of these. You get a panel, open the panel up. Wherever your bolt's at, check it to make sure what's the temperature. And as long as you're around 86 degrees, you're fine. If you're above that, what's causing it? So you have to be careful with it. It's always nice to do the thermal, you know, checking motors, checking transformers so they're not hot, switch gear. It says table figure 1813 lists various types and equipment commonly tested. When used in conjunction with the periodic maintenance and inspection, these tests will keep equipment operating efficiently for many years. Okay, we got it on here. There it is right here. So insulation resistance, testing guide, yes, yes, yes. High potential, yes. Power factor, motors and generators. So you want to make sure that the power factor is within a certain level. If the power factor is too low, you might want to put capacitors to increase your power factor. We will talk about the capacitors and power factor. Power transformers, instrumental transformers, arrestors, polarity. Always check your polarity, make sure it's right. Your windings, yes, you check your windings. Make sure it's turning in the right direction. Make sure you don't have to put it backwards also. And then on the transformer, check your liquid. So this is just a test guide on things that you need to test. Okay, what do you use? Well, it depends on what test you're doing. Okay, depends on what test you're doing. If you're checking temperature, you're good. You know, you're checking resistance of insulation, you get a megger. Always go this way because the ones I had back in the day were crank. I've never used one that was electronic. We had one, but I never got to use it. All I ever used was the crank one, and it sends out voltage signal. Alright, troubleshooting motors. It is fairly difficult to distinguish dual voltage motors as Y wound or delta wound when identifying tags are no longer visible or missing. However, there is an easy way to check. So if you have, when you have a delta motor, the windings are different from a Y motor. One is a 12208 or a 277-480 or a 240-480. Your windings are different depending on your input voltage. So how is your motor? Is your motor a Y or a delta? So as you can see here, here's my Y. So you can see that 1 and 4 are tied within the same winding, and then there's a common connection in the Y in the center. So 7, 9, and 8. Okay, and they make the tie here. So this is my Y. 2 and 5, 3 and 6. It says it can be seen in the illustration T1 and T4 is a 2-wire circuit. T2, T5 is another 2-wire circuit. T3 and T6. Here, here, here. And in the third 2-wire circuit, T7, 8, and 9 form the 3-wire circuit. When troubleshooting, you must determine which circuit is which. I will send you a link on the video how you can find these. You can also read it. It says use a continuity tester or ohm meter, connect one probe to any of the T leads. So when it's talking about the T leads, the motor usually has the 9 leads. So T1, T2, T3, T9, all the way up to T9. And with a delta, it's the same thing. The circuits on the wire remote says connect the probe to T-level, check for continuity, identify leads T7, T8, T9. Why? How can you do that? With your tester, you go to one lead. If there's no leads, we don't know. There's no nameplate on the panel, on the motor, and all you got is 9 leads sticking out. You got 9 leads sticking out. Well, you need to identify and find how you're going to hook up this motor if you don't know what your leads are. So when you touch one, and then you can go across the motors, okay? If you grab one wire and you put your lead on it, and you go to another wire, and it gives you a reading, okay, a good reading, instead of an open line, or it's a high resistance number, okay, so you're reading across the windings, so you're just reading up what they think. So when you get one and the number comes down, and then it means those 2 windings are tied together. So you can check it with an ohm meter. All you have to do is put it on ohms, or put it on the bell. You know, if it's a contact, it's going to make a noise to it, inaudible sound. Okay, if you go across and you check the other ones, and all of a sudden you get it on a 3rd wire. Now you know you got a Y, and you got the T7 and 8. Which of the 2 are they? I don't know, but you got, at least you know you got your 3 wires, your main wire, your center part. Let's connect leads to a 2-touch source and run the motor, turn off power, and connect 1 and 7. And then repeat. So in order to find, where's mine? Okay, if I get one, I touch one lead, say I grab one lead, and it goes to another one. So, and I can't find a 3rd match to it. So more likely I either got the 1 and the 4, the 5 and the 2, or the 6 and the 3. Okay, so I can find my matches. Find my 3, find my pair of 2, find my pair of 2, find my pair of 2, and then you can work from there. Depending what the voltage is. It says ohm meter says let me go back here real quick. It says connect lead, identify the lead to a 3-wire circuit, the T7, T8, T9 in any order, temporarily mark the leads and the 2-wire circuit T1, 2T, T2, T5, T3, T6. So once you get your pairs, once you get these 3, then you get your pairs, you can temporarily identify them. It says connect the 3-wire leads T7, T8, T9 to a 230 volt source and run the motor. Each of the 2-wire circuits should have an induced voltage of 120 volts. This can be verified by connecting the voltmeter to pair of leads T1, T4, T5, T6. So once you have once you have these identified, if you connect these to 240 volts, and then so you bring a hot here, and then maybe the other hot here. Okay, so now you can pick up your power. Okay, so you should be able to pick up 120 volts here, 120 volts on these two, and 120 volts on these two. Turn off power and connect terminal T1 to T7. Apply power to run the motor, and then read the voltage between T4 and T8. If the voltage reading is 330 volts to 350 volts, T1 and T4 are correctly identified. If the voltage readings are 120 volts, the label for T1 and T4 need to be switched. Okay, so if you're going to here and you're reading, you're sending in, and your voltage is right because it's going across this winding. So as you go across that winding, it's going to increase the voltage. For delta wound, it says ohmmeter to identify the 3-wire circuit. Determine which set of terminals is common between the two. Mark common leads 1, T1, and others T4 and T9. Place jumper between T7 and T4. Read the voltage between T1 and T2. Connect T6 or T8 to T9. Voltage reading of about 460 volts between T1 and T3. Now, I'll send you a link. I wish I would have had the picture where on, they got a picture 1815 on page 235 and 256 where they're doing the leads. These leads, how do we tie these leads in? These leads are all dependent on the motor. So depending on our voltage, we know our 3 windings, all our windings, if you pay attention to the windings, let me go back over here real quick. If you can notice that what's a common thread in all of this? They're all multiple of 3. 1 plus 3 is 4. 4 plus 3 is 7. Okay, 3 plus 3 is 6. 6 plus 3 is 9. 2 plus 3 is 5. And 5 plus 3 is 8. So they're all common in these windings, so it's easier to pair them up. You may not have this one or this one done. Okay, so how's the voltage going to be? Is sometimes we have the voltage coming in and we have a higher voltage. We're going to tire this, and here, and we tie in one hot here, one hot here, and one hot here. Okay, we have a different voltage, and then our leads change. So, I drew a blank on it right now. I'm sorry. So how we tie this depending on our voltage, but our leads and our windings, and you can see they're all a multiple of 3. 3, 6, 9, 2, 5, 8, 1, 4, 7. Okay. And on page 256, it gives you an idea on how you would test, how you would find these windings. For the most parts, most motors, even when they're rebuilt, they do put labels on them, so you can know what it said. They may not have a nameplate. We've had them where they come in, the nameplate's gone, 15 horsepower, 20 horsepower, 40 horsepower, and then it's written down with a Sharpie on the top. But all the wires are labeled, so you know which is T1, T2, T3. So each one is labeled. Okay, y'all have a good one. I'll send you this. Later on, I'm going to send you another video on for the final. All right, and then tomorrow we'll have the Zoom. In case you have any questions from the video where I'm talking about the final. Alright, you have a good one. Stay safe.